Hey guys, welcome back, algebra students. Today we're going to continue on in weighted averages. I know we're doing what your favorite topics are. We're doing word problems. But again, just like yesterday, I'm going to work through the problems for you. But you are responsible to write your answers down. So we have uniform motion problems. Motion problems are another application of weighted averages. Uniform motion problems are problems where an object moves at a certain speed or rate. Use the formula d equals rt to solve these problems, where d is the distance, r is the rate, and t is the time. So, example: Bill Gutierrez drove at a speed of 65 miles per hour on an expressway for 2 hours. Then he drove for 1.5 hours at a speed of 45 miles per hour on a state highway. What was his average speed? So, speed is your distance over time. So the first thing they did was he drove at 65 miles per hour for 2 hours. So 65 times 2 will give us 138 miles, plus 45 times 1.5. Let me 45, which would be 67.5 miles. So you add up the total miles and you divide by the total time. So 3.5 hours. So that's 197.5 divided by 3.5, which is 56.4 miles per hour. So that's how much his miles per hour were. His average rate, his average speed was during that time. So I'm going to go and do some of these problems with you guys. Mr. Anders and Miss Rich each left and drove home from a business meeting at the same time. Mr. Anders traveled east at 100 kilometers per hour. Miss Rich traveled west at 80 miles per hour. In how many hours were they 100 kilometers apart? So the first thing we need to understand is we need to understand what's going on. So this circle right here is their business meeting. Mr. Anders is going east. So Mr. Anders is going east, and this we'll call this A, at 100 kilometers per hour. And Miss Rich, we'll call her R, is going west at 80 kilometers per hour. So, first thing we notice is they are going in opposite directions. So that's important for us to know, because we want to know how many hours are they 100 kilometers apart. So, if Miss Rich is going to the left or west at 80 kilometers an hour and Mr. Anders is going to the right or the east at 100 kilometers per hour, we add their rates and then we know how far apart they are. So I'm going to set this up as 100 kilometers per hour times our time, t, plus Mrs. Rich, her time, so 80 kilometers per hour times t. And we want to know, when does that equal 100 kilometers? 100 kilometers. So that's our function. So when we solve this, we get 180t equals 100, and we divide by 180 to both sides. We get t equals, and I'm going to put this as a decimal, t equals 0.55 hours. So approximately a half an hour or 33 minutes. But we're good with leaving it at 0.55 hours. All right. An airplane flies 750 miles due west in 1.5 hours, then turns around and flies 750 miles due south in 2 hours. What is the average speed? So we're just going to set this up. The average speed is the total distance. So speed, we usually call this V, velocity. Speed is the distance over time. So what we have is 750 miles west plus 750 miles south divided by 1.5 hours, 1.5 plus 2 hours. So what we get is 1,500 miles over 3.5 hours. And when we divide, we get 429 approximately. We get 428.6, which I'm going to round up to 429 miles per hour. And that's what they get. So now I'm going to do this one. Sprinter A runs 100 meters in 15 seconds. Sprinter B starts 1.5 seconds later and runs 100 meters in 14 seconds. If each of them runs at a constant rate, who is further in 10 seconds after the start of the race? Explain. So first thing I want to do is I want to start with Sprinter A. So Sprinter A has, let's get Sprinter A's speed. So 100 meters in 15 seconds. Make sure that looks like a 5. 15 seconds, which equals 6.67 meters per second. All right. So now what I want to do is at 10 seconds, I want to see how far Sprinter A was. So distance equals rate times time, which means our rate was 6.67 meters per second times our time, which was 10 seconds. Our seconds cancel, and we get 66.7 meters. So that's Sprinter A. Now we're going to do Sprinter B. Sprinter B, first thing we want to do is get the rate, which is 100 meters in 14 seconds, which gives us 7.14 meters per second. So Sprinter A definitely runs faster than Sprinter B. But remember, we have this 1.5 seconds that we're going to deal with too. So our distance is going to be our rate times time. And our rate is 7.14 meters per second. But our time is going to be a little bit different because it's going to be 10 seconds minus 1.5, because we're going to subtract out this 1.5 seconds because Sprinter B started later. So minus 1.5, which equals 10 minus 1.5 is 8.5 seconds. So we're going to multiply 8.5 seconds times 7.14. The seconds cancel, and we are left with 60.7 meters. And so the question asks, which one is further? Who is further? So Sprinter A is 66.7 meters. Sprinter B is 60.7. So that would mean Sprinter A is further. And you don't have to write A is further. You could just circle it. but sprinter A is further. All right, let's look at the next one. An express train travels 90 kilometers per hour from Smallville to Megatown. A local train takes 2.5 hours longer to travel the same distance at 50 kilometers per hour. How far are Smallville and Megatown from each other? So the first thing we want to do is they're traveling the same distance. So remember, distance equals rate times time. So we have distance for the express train. D equals 90 times T. 90 times T. That's for the express train. Now we're going to do distance for the local train. It's 2.5 hours longer at 50 kilometers per second. So the distance for the local train is going to be 50 kilometers per hour times T, same T, but we're adding 2.5 hours, so plus 2.5. So if you notice, both of these D's are the same. So we can set these two equal to each other. So now we have 90T equals, let me fix that, 90T equals 50 times T plus 2.5. I'm going to let you guys solve that part on your own. I'm just going to give you guys the answer here. Remember, we distribute the 50T, subtract it over, divide by 50 times 2.5 is 125. 125 divided by 50. We get T equals 3.3 hours. But we didn't want how long does it take for the express train to get there. We want how far apart are the two places. So we're going to plug this T into either one of these two equations. And I choose to do the first one because it's more simple. It's just 90 times 3.3. So D equals 90 times 3.3, 90 kilometers per hour times 3.3 hours. And that equals 281.25 kilometers. And that's our answer. All right. 2 more problems and then we're finished for the day. Cycling. 2 cyclists begin traveling in the same direction on the same bike path. So remember our first problem, they were going in opposite directions. So what we have is, here's our point. We have one cyclist going, and then we have another cyclist going. All right, so they're going in the same direction. So this is going to be a little bit different of a setup. So one of the travelers, 15 miles per hour. So we'll put the blue at 15 miles per hour. And then the other one is 12 miles per hour. 12 miles per hour. All right, and we want to see how long until they are 10 miles apart. How long will it take? So clearly this the blue rider is 3 miles per hour faster than the green rider. So what we need to know is they're going in the same direction. So in this case, we're not going to add the two to find out the distance. We're going to subtract the two. So we're going to do, remember, in our distance equals rate times time always. So we're going to start with the blue one. We're going to say 15 miles per hour times t, and then we're going to subtract the green rider, which is 12 miles per hour, times same t, and we're going to say that equals, well, we want to get it to equal what? We want it to get it to equal 10. So 10 miles. So we just solve this. We get 15 minus 12 is 3t equals 10. Divide by 3 on both sides. T equals 3.33 hours. So it will take 3.33 hours for them to be 10 miles apart. All right, next problem. We have 2 trains leave Chicago, one traveling east at 30 miles per hour, one traveling west at 40 miles per hour. When will they be 210 miles apart? So, if we're going to draw our picture here, all right, this is the train station. We have the red train going east at 30 miles per hour. All right, and we have the green train going west at 40 miles per hour. And we want to find, when is their distance going to be 210 miles between them? So this is very similar to problem number 5, but a little bit different in the fact that they're going in opposite directions. So we're not subtracting their rates, we're adding them, because every hour they're getting further and further apart rather than going in the same direction. They're adding each of their times together. So we have, I'm just going to do this right here in green. So we have going west, we have 40 miles per hour times RT, plus we have 30 miles per hour times T. And we want to see, when does that all add up to 210 miles? So 210. So we get 70T equals 210. Divide by 70. And we get T equals 3 hours. And that's it. That's your answers. Any questions, reach out. Make sure you're writing in your work. Thanks, guys. Have a great day.